Are things going smoothly on your Agile team, or are they chaotic? Today, I'm going to break down the operational factors that will affect your team's ability to deliver software. In this video, we'll cover some of the practices that allow your team activities to run smoothly and recover from surprises. I'll talk about the practices of continuous integration and deployment, what planning a release looks like, and the timing of events in your iteration or release calendar. I'll talk about some of the things that you can do to deal with surprises or urgency, and what to do once the dust settles. So with that, let's start with practices that can help your releases run smoothly. Number 1, align your tickets and features to commit messages. In most software development lifecycle suites, this means that you can navigate between the feature tickets that describe the work and the changes or fixes that were made to implement a feature. On the teams that I've run, I've made it clear to my developers that this is mandatory. The payoff is huge. If you find a line of code that does something you don't understand, then you can surf through the git blame output and across to the ticket where the changes were described, or from the ticket to the pull request or a revision with the changes. This is a superpower. When surprises occur, you'll be able to mine this to determine why. Number 2, keep track of the releases each ticket or feature is in. If you do this, you can talk with non-technical stakeholders about the timing of releases, and discussions about dependencies can be clearer at a deliberate tactical level that the project manager or release coordinator will understand. Oftentimes, this will correspond to the branch that the feature lives in. Where I currently operate, an entire release is promoted from the dev environment to the stable environment all at once. Number 3, keep track of whether a feature has been tested. This is often done with a swim lane on the Agile board. This is helpful for determining the timing of code freeze for a particular release, and knowing which of the features in the release have passed testing is a good and healthy thing for your QA staff. Number 4, run a code freeze or a feature freeze for stabilization. A code freeze gives the stable software a chance to receive a regression testing treatment. A code freeze doesn't have to be a hard rule, but can instead be an expectation that only bug fixes or urgent changes required for the code to be fit for production can be made. If you do this at the same time as you promote from the dev environment to the stable one, then it means that developers can continue to work on features that will qualify for the following release. Number 5, prepare a runbook. Yes, it's good and sensible to automate everything, but there are going to be some things that aren't necessarily automated, such as sending comms to the specific people that are affected by a new feature, or a manual data fix that would be awkward to put into an automated migration. Sometimes there may be a train of tasks that need to be run in a particular order for the release to be successful. That's okay. It's a good idea to start your runbook at the start of the iteration so that you can capture any things that diverge from the normal. Let's talk about your environments. If you aren't already running a dev environment, I'd encourage you to spin one up. It's a great place to integrate your code together and test for expected behavior and also any unexpected side effects of changes that you've made. So many times I've noticed that when you have different developers working on different things, it's not even until the code's together that there are surprise interactions. A stable environment is a great place to put your code while you're stabilizing a set of features ready for production. Ideally, you would only make changes to the software in this environment if you have to. Having a planned regression test suite is a good idea and something that a dedicated quality assurance team can get very practiced at owning and running. A great and now fairly well-regarded idea for keeping your environments up to date is what's known as continuous integration and deployment. This is a pair of practices that basically involve regularly and automatically building and deploying software to the environments. This often involves building whenever a new source code is pushed to your Git repository, and might include building on a feature branch and running a suite of unit or integration tests. Building, testing, and deploying to an environment whenever that environment's nominated branch's tip has a new revision, or the use of tags for keeping track of version numbers, perhaps to provoke a deployment. Quite often, this isn't all that complicated if you store your code in a Git repository and you can write a bash or PowerShell script to build your code, then you're halfway there. There are lots of different ways to accomplish this now, and I've listed a few options on this slide. One comment that I'll make on this topic is that if you've ever had to run a manual build and deployment process, it's pretty tedious and error-prone. Yes, I've recommended that you use a runbook for your deployment procedure, but most of the time, business as usual builds and deployments will involve clicking a button to promote the logic and then waiting for several processes to complete automatically. I assure you that once this is in place, you won't want to do it the old way again. While we're on the topic of continuous integration and deployment, it's a good idea to abstract your build and deployment processes into a mostly shared set of procedures, scripts, or actions that can be performed in each of your environments. What this will mean is that, especially once components are in place, is that surprises when rolling out to production are rare and will be limited to the cases where a configuration value has to be set manually and has been forgotten. If you're on the ball with your runbook, you'll find the cases such as this are rare also. Some choices that you'll have to make in your build system are how big each build should be. Where should you draw the lines between different modules that may be able to be built independently or skipped if nothing has changed? This requires a careful balance. I found on more than one occasion that switching to a monolith repository adversely affected the build times. Having a slow build system will lengthen loop time and hurt your agility. But separating modules inappropriately will lead to a lot of busy by hand kickoff work like synchronizing merges which will otherwise also have a similar effect. I think a good middle ground is to have a set of modules on a single repository that build only when specific examples change. Although as an architect, you'll have to weigh this up against developers' propensity to want to centralize code, which will tend to provoke larger builds as a regular occurrence. Modularity and reuse are a fraught topic and probably deserve a video of their own. A release calendar sets up the timing of different activities during an iteration centered around the activity of releasing software. This can sometimes align with the timing of the last day of an iteration, but in my experience, which is mostly with long-running projects, this date will often spill over into the week following the end of the iteration, with code freeze and regression starting near the end of the sprint. This gives developers a chance to start working on new tickets while the test analysts are working on the regression test, but can also produce a flurry of interruptions when developers would otherwise be most productive. You and your team will perhaps want to test different timings of this and other ceremonies such as planning or retrospectives to avoid disturbing flow time. But regardless, having a stable schedule that provides some routine and some certainty is worthwhile. Having an expectation of a release date will also be helpful when discussing timing with stakeholders. If you're roughly taking the same amount of work into each release, then the duration of the sanity check will be roughly the same time. The scheduled date is very often chosen to be the first half of the week, and this gives room for production problems to surface and be fixed before Friday. Deploying on Friday is typically considered bad form, particularly for systems that have high availability, because anyone on call over the weekend will have an elevated risk of having a call out. It's because of this reason that I typically recommend that your in-band release time should be on a Tuesday afternoon or evening, giving time for early problems to surface on Wednesday and be fixed and deployed on Thursday evening. Sometimes problems can slip through even the most thorough process. A good way to deal with this kind of thing is to have a lighter weight process that you can employ in a hurry to quickly restore service. You'll need to determine when bugs are important or impactful enough to fix in a hurry, but in many cases, cases, waiting for the next release window isn't at all feasible, so having a way of preparing a patch or a hotfix is useful. A helpful metric to think about in this circumstance is the time to restore service, and any blockers that get in the way of doing so should be there only because they need to be, to ensure safety and to quality check the work. It will actually fix the problem. Quite often this kind of fix will happen outside of the normal hours for a release, such as during business hours. When you want to do this kind of change, it can be useful to know that your changes won't cause any extra outage. So if you're not lucky enough to have zero downtime deploys, then you'll want to have some way of notifying your users that you're having technical difficulties. You might not feel great about the solution that you've arrived on to deal with the crisis. Once the dust has settled, you will have time to think about a more permanent solution that you and your developers will feel more comfortable with. Take some time to think about the urgency of coming up with an elegant solution and schedule it if it's genuinely necessary. This should be rated against the other technical debt that your application will naturally accumulate as a result of choosing pragmatic solutions over the long term. Developers should have a way that they can communicate discomfort or concerns about the code base and a way of suggesting improvements to it, such as a retrospective. I will caution you though that refactoring can never be finished, and at some point it becomes indulgent. No real software will ever be completely pure of compromises, so be sure you can take a sober look at the return on investment. Did you like this? Have questions? I'm working on some material for software developers and architects to make sense of the mess of software development. I'd love to hear from you. Talk to you then.